data wrangling and munging, I'd like to just start off by saying wrangling, as in terms of my understanding and my definition, that's almost the transforming of data, and munging is the cleaning and the data quality side of data. So what we're wanting to do today, or what I'm hoping to do today, is give you a step-by-step transformation journey process that you can follow to achieve your transformation goal. Okay, so you'll see that it's similar to like a data management maturity assessment. You don't need to go all the way to the end, but you can go to where you want to go. And we'll try to get you there as fast as possible. Because the chances are that you are feeling, and especially if you're playing around with lots of data sets, and again, I'm not referring to those data sets that have been produced by your BI team. I'm referring more to ad hoc data that you're getting externally from the internet, from open source, that you're getting from ad hoc surveys. It's this type of data that I'm referring to. And typically when you get that data, you start to experience what accountants commonly refer to as Excel hell. They live in Excel. This thing starts to break. The data doesn't balance. You're wasting so much time on just getting this data into the right format. And then the biggest problem is that you don't have enough time to do the analysis. You then really live in fear of presenting the data and it's wrong. And it's this frustration of fighting with data. So that's what the goal is. And we're wanting to show you techniques, patterns, and stuff like that, that you can reduce a lot of this pain and frustration, okay? And that's getting to the point that you want to get to where you can answer the questions that were asked. Why did you get the data in question? What was the purpose? Or provide valuable insights. So sometimes you can't always answer the question, but you can give valuable insights. Guys, and if you would like to, please put up your hand or mention something, and Paul or somebody will pick it up and interrupt me. Okay, so what's the agenda?
Sorry, Howard. Yes, Johan.
Yes, Johan. Well done on getting the book.
Yes, actually, thanks very much. As I've read it
Nice.
just briefly. I guess I haven't had time, but I'll actually read it this week in detail. Actually, sorry. Actually, I just wanted to. Actually, why am I? Because it was actually the previous page. Like what we talk about is this data wrangling and actually munging. What was it?
Munging.
Why do we have to have these new buzzwords for things which we know is data wrangling, is fixing your data quality and data munging? There always seems to be basically every 5 years there's some new buzzword to actually confuse everybody.
Yeah, and so you're right, but it's interestingly enough, you've got a series of data scientists that have come on board. They've come into the domain. They've been given a whole lot of Excel data that's not in a pleasant shape, and they've been asked to answer questions.
Sorry to interrupt you. So does this mean this really comes from the data scientists?
Yes,
they kind of take the
data scientists, statisticians, econometricians, and stuff like that.
Okay.
And I think the root comes from the fact that we as BI developers, as whatever it is, we can't keep up with the pace, not in the current setup, and we certainly can't deal with all the data that they're picking up from external sites and stuff like that. But I think and this is what I'm going to try to do, is I'm going to try show you how we can start building communities of practices, journeys, techniques, and stuff like that, so these guys don't live in Excel hell for half their lives.
All right, thanks. Okay, so that just means we need to put this all in our glossaries.
Yes, cool. You got it. And there's a few more. So hold on to your horses. I'm going to give you a few more terms that you may think you've never seen them before. I know I wasn't, but I've certainly learned in the last 2 or 3 years that I've got to start learning to speak the speak of the the data scientist, the statistician, the econometrician, and things like that. So it's time for an upgrade and a reboot, John.
Cool.
All right. Fantastic. So the agenda is we're going to show you a transformation process to achieve trusted data transformations. And this is assuming that you're dealing with messy data, right? So I'm not assuming that you're dealing with business process data that's come from a line of business that someone ETL'd and got it into a data warehouse format. Please, that's not the game. I'm addressing that issue of why are people saying that, and data scientists saying 80% of our time is wasted time. It's spent on wrangling the data and munging the data. So that's the area. And how do we help them? And we can help them in several ways, and I hope to show you that. Okay. All right. So then discuss how do we reduce that time? I don't believe that we're ever going to get away from wrangling and munging. I don't think it's possible. But we can certainly do a lot to overcome some of the challenges. How can we reduce the pain? And then discover how you can transform from your brute force approach to a knowledge-driven approach. Okay, so that's the agenda for today. All right, so what I wanted to then go into is, I'll come back to the pre-phase qualifier. I wanted to just go into almost a 20-second summary of what this talk is about. Okay, so this is my elevator pitch for the talk. And so in summary, it's to provide what I call a data truth transformation journey so that you can derive meaning, to answer questions, and to provide valuable insights. Now, I've chosen some of these words on purpose. I've chosen the word of truth and I really liked what Scott Taylor presented to us last month in terms of truth before meaning. I don't know how many of you guys saw that, but I think it was very valuable. And the truth refers to the foundational data management concepts and capabilities that need to be applied to the data before you start searching for meaning, being the analytics. Okay, so I'm here talking to those that are going to help the data scientist get these techniques sorted so that they can do it, and I'll show you the transformation journey, or start to build data teams that can help it. Now, I did a presentation on Thursday about data teams, and when I looked up on Google, it was all about data engineering, Amazon, and moving data as fast as possible. And I realized that we're actually missing something here in terms of working with our existing data scientists that are just pulling data, open data in different formats and stuff like that, and they've got to get it to work. Okay, so let's do a bit of a precursor. The precursor I wanted to talk to you about was show you some of the analytical and analysis terminology and concepts that they focus on. What is the problem? Why are we munging and wrangling? What has caused the problem not to be solved? And there's an interesting debate. What is possible? What's our vision? And what's so different about this approach? Now, I am also, and it's a pity that I miscommunicated that or didn't realize that Guillermo one was actually part of big data. So otherwise I would have brought in some of his screens. So I thought you'd all have watched it last month. Sorry about that. Okay, so let's get some format. Let's get some basic definitions right. And this was very interesting. This came from a research paper that an academic did their master's on, right? Okay, so this is no slouch getting this stuff together, and it was specifically done for data scientists. And he defined a tidy data format as a set of 3 interrelated rules which make the data set tidy. Each variable must have its own column, and I'll show you a little bit more. Each observation must have its own row. Each value must have its own cell. And he's then really simple in terms of saying a messy data format is one that doesn't adhere to the tidy rules. Okay, so that's really nice. And then they've got a code book, which is, and I don't know if any of you guys are working with Jupyter code books, are you supporting any of your statisticians in that? They bring in a lot of their transformations, the raw data, the recipe data, and stuff like that. So it's actually quite helpful to be able to recreate the analysis that these people did. Okay. So some basic terminology. This is a little bit more in terms of the tidy definition for statisticians. Here you can see that these columns are variables. And for example, that may be a GDP rate, it may be a yield, it may be a bond value, capital bonds, it may be all sorts of whatever measurement unit you have. And that's called a statistical variable. And I'm sure you've seen some of my diagrams on having complex analysis, and they call it a multivariable analysis. That's one of the techniques. And that's when you have multiple variables that you need to compare. Then you have an observation, which is equal to a row. And then you have a value, which is equal to a cell. And an observation, another term for an observation, is a data point. So I'm sure you've heard everybody say, oh, I've got a million data points. And you think, oh, is that a million data sets? Is it a million, whatever it is? No, it's a million rows. And it's the entire row. So it would be for a specific date, within a specific context, what was the observation at that point, for that point in time. Okay, so here I've brought the tidy data definition back again. So each variable forms a column. Okay, so there we have a single variable, single column. Each observation forms a row. There we go. And then each type of observational unit forms a table. So the table is referred to as an observational unit as far as a statistician is concerned. Now, they need to get it into these formats. So when they run statistical algorithm or logical regression or whatever it is, it assumes these formats. Okay, and this is actually a copy from the paper that I found all this terminology that they're using, and it helped me prepare this transformation journey for them. Okay. So this is a code book. I actually quite like it. It's a little bit like our ETL, sys package, whatever it is, and it has the recipe. Notice that they expect you to have the raw data. They expect you to have a tidy data set, and then a code book describing the variables. Interestingly enough, that's our metadata, right? And the values in the tidy data set. So they're now talking about domains, which is our data quality. Okay, now this paper actually came about, and I don't know how many of you guys have heard some of the challenges. I got someone's hands up. Mads, yes?
Yeah, hi.
Hi.
Just maybe something that may come later on. There is an assumption here that there is a kind of consistency in this data set. I'm just questioning the tidy definition. I mean, if you haven't, let's say, the right profiling in the columns or the rows or the cells, is that something you'll touch on later?
Yes.
Yes. Right.
Something I'll touch on later. What the author was trying to do was to say he can show you lots of different examples of messy data sets, and we've got to get them into a tidy data set. And this is the general structural format of a tidy data set. Then when you go a little bit further, and I've taken his approach a little bit further in terms of looking at the domains of the elements, whether we've got data quality issues and stuff like that. So yes, we will go into that a bit further.
Right.
Okay, so these are the code books that they make use of, and so it was quite interesting. I liked it, and sorry, the point I missed was this came about. The paper came about soon after the understanding of some of the bad algorithms that dealt with the issue in Greece and with the IMF, when it said these are the suggestions of the types of shucks, I keep forgetting this term, the prosperity adjustments that Greece had to undertake to get more loans from the IMF. I don't know if you remember that there was quite that big panic in terms of that. And then what happened sometime during that phase is that they picked up that the algorithm or the mathematics that was used to understand some of these things was flawed. It was done by a bunch of researchers or economists in the US. They found it was flawed. Fortunately, they had the raw data, they had the tidy data set, and they had all the explicit transformations. So they could rework it and they could say, you used the wrong algorithm, you used the wrong mathematical formula, and if you look at it this way, then it comes up with a different answer. So that's when they started to be a lot more formal about what was contained in these data sets and stuff like that. Okay. All right, so what is our problem? That comes back to the statistic that, I haven't got a whole lot of evidence. It's just what everybody talks about. It says on average, data citizens spend 80% of their time extracting truth from the data by transforming and validating the quality. All right. Now, again, I'm phrasing this data in terms of the data that typically comes from external internet, be it open data, be it, wherever they can get the data, and ad hoc server data. So I do believe that the BI guys are doing a good enough job in terms of getting the data and dealing with these issues prior to presenting them. But still, a lot of them find the use of the BI system as more of an ETL tool. They get it into Excel and then they start working. Now, the problem when you get into Excel is that you may be in a pivot table with multiple columns, multiple values in the column, and then you start having some interesting challenges. Okay, so what caused the problem not to be solved? Now, I really like this quote from Leo Tolstoy, which he said, "Happy families are all alike. Unfortunately, every unhappy family is unhappy in its own way." And I certainly have learned through experience that tidy data sets are the same thing. Tidy data sets are all alike, but every messy data set is messy in its own way. Okay, so the possibilities of being messy is phenomenal. I keep on shaking my head each time I get a new data set from the Weather Bureau as an example. But you start to understand why in some cases, because the one data set I played around with from the Weather Bureau, it was something like 240 megs. When I unpacked it and unraveled it, it went from the 240 megs up to 60 or 70 megabytes with 16 million rows. And it was phenomenal what the transformation meant on every single cell. So you start to get an understanding of why they do it, but the pain that they cause in the journey is quite something. All right, so what is possible? Okay, so we need to, as data modelers, we need to recognize these data formats that support analysis. We need to master the transformations that are required. We also need to define the principles, policies, practices, almost basically what's appropriate for these guys. We need to define that data management principles and that, so that when they go through it and they understand the metadata and things like that, it's not too much of a mission. We should be able to use machine learning and automate the transformations and insight detection. Now, this is happening. So the presentation on big data, the guy demonstrated it. Now, of course, he demonstrated it and it was fantastic, but then when you ask some more questions, he said they only were dealing with certain formats. So, for example, they couldn't look at data in JSON and stuff like that, which is it's fine, it's understandable. They just started, but we also know that there's a lot of room to go. And then I do believe in the augmenting the machine learning with knowledge to provide enhanced meaning. So we've seen that work in other areas of AI, and I believe it will work here as well. Okay, so this is the transformation, the truth transformation process that I'm suggesting, that I've been able to, with lots of different scenarios, case studies, work through it, just put together a process. And I typically start off with brute force. And brute force is one of those areas where you basically wrangle every single data set. And what it does look like is that this wrangling tends to result in almost one table within the analytical tool per source data set. So a lot of times people get the data, they get it from an Excel spreadsheet, and then it lands up as a single data set in the visualization tool. So there's very little conformance to a master data, as Mads spoke about. So if I have a variable and I have, for example, country, I would like to ensure that I've got the master data of country. Now, Tidy does not introduce that, and I'll show you how we go on to enhance that. So I go brute force. This is the brute force. Then we start seeing people recognizing patterns. We can say, but can you see that you're doing this repeatedly? You're having to pivot the table, you're having to split the columns, and you can start seeing the patterns that you're using to actually achieve this. And of course, when we start showing them the definition of messy, tidy, all of these different areas, then they start to understand it a lot more. Then we go into the next level, which is informal collaboration amongst the different people that are having to do with it, trying to get the consistencies. And then I'm suggesting that we introduce data teams within the business. We get the data teamwork going so that we can start introducing principles and practices, and I'll take you through this more. Then we get into machine process automation. So we're seeing it already today that the machine learning is starting to classify the data. It's starting to using data quality classifications to determine data that are outliers and maybe have problems. So that's already happening. And how do we extend that with a knowledge-driven transformation? Now, when I look at the bottom here, we're seeing that this is where most of the time is getting wasted. All right, when we're doing this brute force approach. So every single step that we take, we are improving the speed at which we deliver, and I believe that we're going along this triangle of data, information, knowledge, and wisdom. So there's some real benefits that you get as you progress along this process. Okay, so this is the data modeling for analysis that I've spoken about. The amazing thing is that a lot of it's sitting in R packages, open source packages that you can download. So for example, he has a package that actually helps you create tidy data. There's also one on Python, which then they're using the same terminology. I believe it sort of started coming out of this paper that was published. And this is the typical journey that I've put together. This messy and tidy is what I got from the paper. And then I applied our normal Kimball methods in terms of getting a star schema to get a narrow data set. Because tidy data set doesn't mean that it has a universe or a domain defined per variable. And that's typically what you're doing when you go from tidy to narrow. And the nice thing about that is you're starting to introduce all of your data quality definitions. You're starting profiling, and then you're getting definitions of the set that you're dealing with. Okay, so going to a narrow is a very helpful step, but I do believe that that's not the end of it. And a lot of times we're stopping there, and hopefully the guys who attended the bridge or the USS discussion by Francesco Pupini will remember that he developed that bridge table. And there we go to taking the narrow, so we're enhancing the Kimball data set and we're creating a bridge. And from the bridge, we can create the wide data set, which is what some of the statisticians require as well, depending on the type of analysis that they want to do. and I'll show you some formats. Now, notice that these two are really good for self-service and visualization. Okay, USS is fantastic from a self-service point of view in terms of, and I'll show you a quick example on Power BI. This was something that JG, I'm working with JG on. I'm not sure if he's on the call, but he gave me permission to share this with you. And if you look at this layout that I've got, and we'll do it as a case study, you'll notice that I've got the fact tables at the bottom, I've got the dimensions at the top, and I never get into the circular references that I get into without the bridge table. Okay, so I'm certainly seeing tremendous value when I make use of the bridge, I connect my dimensions to the bridge, and then each time I get a new fact table, I just connect it to the bridge and I'm all done. And I don't need to go and join all of the other areas up, and it certainly gives me a lot of value in building self-service analytics. Basically, when I come in here and I drop the tables in, the Power BI is able to understand all the relationships without me having to do anything, which is fantastic. And you don't get any of those dotted lines, and this one doesn't link to that one, which is great. Then a wide data set, and I'll show you an example of that, is where you'll find that some of the times the data scientists cannot use the narrow and the USS format, right? Because it's just got a whole lot of numbers. And what they want is the dimensions have to be flattened into one big table so that they can goal seek across the tables. All right. Okay, so that's the process that I've put together. Here is some examples I won't go into now. There's the different formats. These are the different transformations. They actually call it melt and star and union and flatten. So this is some of the terminology that we picked up. And then these are characteristics of those different formats. All right. And I've given some details in terms of how do we go about. So we need to, when we have messy, we need to melt it to get the tidy. When we got tidy to narrow, we use the verb star, and then we union from a narrow to USS, and then we flatten from USS to, it's almost a tidy and wide. You can go back to a tidy and wide because they don't want the numbers. They don't want the fact that country South Africa is a number 1 and Zimbabwe is 2 and Botswana is 3. They don't want that in the goal seeking. The algorithms and the correlations don't work with that very well. Okay, so in summary, what is so different? This is a transformation journey, and we can help the people move along that journey. All right, so the next phase I wanted to just check before going into the details of the process, and I know I've explained it to you. I want to just, if you wouldn't mind, within the chat box, in sharing with me what stage or what phase do you guys currently find yourself in? If you wouldn't mind just putting in the chat box, are you in, or most of your data scientists, and when I refer to you, I mean your organization and the people that you work with, where do they typically find themselves? Okay, brute force, yeah. So each time we beat the data, each time we have to apply all this issue. Okay, nice. So the data teamwork, and I'm assuming now your data teamwork means that every single time that the business find a new data set, they would allocate it to the team and they design to help them clean up that data set. Any others? That's great, Clive. You guys, you're quite far ahead. Clive, are you finding similar challenges to these transformations that I've shared in terms of going from messy to tidy? Is that something that you guys have got well defined?
Hi, Howard. I think where we struggle is actually just having some fluidity in the actual teamwork.
Okay.
I think
okay.
all the skill to get everything done. It's just a matter of getting it across our teams.
Right. So that's really nice when you come to teamwork, and I'll show you these transformations, is you want to get things in place so that by the time you've got this data team, you've got a lot of practices and transformations defined that they can follow and get through. Okay, great. Anybody else? It doesn't look like too many other people want to contribute. Okay. All right. So we've got one on data force and the other one on data teamwork. Certainly my experience has been, for most of the scientists that I've been working with, they're in brute force. Very few of them understand the patterns. Very few of them have built informal collaborations, community of practice. We're working with one of our customers to get this going, and they're really comfortable in going through this reading groups and transformations and defining the rules. So that's quite nice. Okay, so let's go through the process. So this is what I refer to as the data truth transformation journey. I'll take you through all the details, so don't worry too much about straining your eyes. What I can show you is just as we're progressing, we're building, right? So, for example, we're starting off at brute force. The characteristics of brute force is I wrangle every data area in Excel. Now, this is always the pain when I pick up some of these messy data sets. In one spreadsheet, I could find 3 or 4 data areas. So the fact that you've got 10 spreadsheets doesn't mean that you've got 10 data areas. It could mean a lot more. Okay, and then you typically land up in one table per wrangle. And then when people start to, this is what I refer to as an exit condition. So when I go and do an assessment of customers to see where they are, I can say, right, you're starting to identify common techniques. You're starting to share packages. You're starting to understand what tidy looks like. And then, so we look for these different elements and to understand where the customer is. So let me take you through the different areas. If you have any questions there, happy to take. So this is the brute force. Okay, so the characteristics, I shared a little bit about it. And in this situation, I hardly ever find any data quality happening. The guys are so happy to get to the end result where all this data is there, and they fight with the data visualizations. And let me give you an example of what something that looks like. Here is an example of a data set. And you can see there's a data set for 2015, a data set for 2016, a data set for 2017, 18, 19, and just about every single data spreadsheet that was there, they created a new data set. And it's not uncommon. This is pretty normal with what we're finding. Okay, exit conditions. There's common techniques. People are starting to do it. And then people are getting tired of the time that it's taking and the pain and frustration, and say we've got to do something about it. Okay, so the next step is what I've referred to as pattern development. All of a sudden, people are looking at goals to Google. They're Googling tips and tricks on how to do these transformations. They're starting to go to webinars, listen to webinars, look at it, and they're starting to recognize structures and data formats. Okay, so here's just some of the characteristics that I've noted and put down. We're starting to get efficiencies from pattern application. We're starting to get webinars, reading groups together to address the techniques across the team. The team are trying to be consistent, and we're starting to recognize data structures. So with the one customer, yes, Carl, we in terms of getting to a formalized data modeling, you're right. It's nice to go there. So this one that I picked up is a lot of it's on STMX and GSBPM. So that was quite interesting. When we first started with the statisticians, we started picking up STMX, and I don't know how many people, just with a show of hands, any people who've dealt with STMX, but the really nice thing I like about it is that it's the statistical data and metadata exchange. So when they ship data, they don't just ship all the data points and all the columns and stuff like that, which could be in a messy format. They're supposed to ship all the metadata that's associated with it. And this links into something called a generic statistical business process model, where they have well-defined ways of dealing with surveys and things like that. Okay. So the exit conditions from this is you start to see emerging patterns. And what I found in this scenario was I started to find data models. Okay, so one of the customers I worked with, we had a brief discussion on STMX. It wasn't 2 weeks later where they transformed all their series and their database designs into an STMX design. So they had the observations and the different terminology that STMX had applied, and they basically got all their time series into those transformations. So it was amazing just that transformation, what it did. And the person who was building the database, he could then explain to all the statisticians how he had designed it and how they needed to work with it. So it was an interesting jump that they took in the maturity. Okay. Then I spoke about informal collaboration, working with a community of practice. We start to publish white papers like the Messy and Tidy. Clive, I'll share that with you. But the white paper that we put together is how do you go from messy to tidy to narrow to USS to wide. Now, you don't always have to go to wide. If you don't need that wide data set, then you don't need to worry about it. You don't need to go through all those steps. We've also put together a proof of value to demonstrate the benefits of the transformation process. So how much time can this save? And then the nice thing about this area over here is we start applying the data management fundamentals. How do you get DQ? What dimensions? How do you validate the data? How do you use the metadata? That code book, that was fantastic for me when people brought up this code book and the Jupyter code book, and I said, but here you see, here's all the metadata, guys. So when I ask you to define the terms and the columns, this is what we're expecting. So this is not a weird thing that data governance has tried to bring in. This is something that you should be doing. And data modeling. And I must admit, when I first opened the word or tried to suggest a data model, like Carl was talking about, they thought it was an algorithm, which, I mean, that's what they build models. They build statistical models. So we had to undo that terminology confusion. Standardized data structures. Now, this was fantastic in building that common data structure, and I'll show you some of the outputs of that. Now, what I found is when you almost need to get out of the informal collaboration when people start asking for standards and principles and practices and things like that. Then informal doesn't work anymore. And you now have to bring in more of what I refer to as a data team. And I like calling it a value creation structure. So you must know now that you've got enough in the previous one, you've almost got enough business value to demonstrate why you should create a dedicated data team. I'm still recommending that stays within the business, but you now have a data team with well-defined roles and responsibilities to be able to perform these data transformations. So the typical things that are happening as part of this phase is business value creation, data team structures, the operating model. Now we're starting to get in defining these. And of course, we start hitting the technology issue now. Should I be using R? Should we be using Python? Should we use whatever it is? Or Power BI or whatever it takes. And a lot of the times I try to not spend too much time in the technology side, just to say, if your data is right, and if it's in the right format, be it in SQL, be it in Oracle, be it in Postgres, then you can typically use whatever tool you want to do with it to visualize that. The problem starts coming in when all the transformations are sitting in the tool then somebody's got to go and interpret it. And that's when we start having problems. But if you've got your curated data in the database, you've got a long way forward. Okay. Then we go into basically the RPA, which is what Guillermo showed us last month, and he's done a fantastic job. I think his number, I don't know how many people were there. I think Johan was there, but he must have had in the region of 250 classifiers. And what these classifiers do is they recognize the data when it arrives. So now they can point these machines at your data lake or your data swamp, whichever you got, and it can go and analyze the data and understand what the data looks like. And it goes quite far in that it can classify the data, it can look at some of the data quality issues, recommend suggestions, apply them, build a data model, build almost a tidy data model, and it goes another level further where it generates insights. Okay, so it actually starts showing you what are the correlations and what's in there. So this was pretty impressive in terms of how far they got. And I'm suggesting the next level is when you start providing this machine learning with an existing business taxonomy and ontology that you've built, then its ability to build that knowledge graph is so much better and a lot faster. Okay. Now, you really, there's not much further that you can go, or I certainly haven't experienced any further transformations that I can get from understanding a knowledge graph and putting it into the appropriate format and having all the metadata and the business rules of association. So you basically got that IDEFO, all the data modeling rules plus more in a knowledge graph. Okay, so Clive's asking a question, is it possible to jump from brute force to knowledge driven? I don't believe so. This is sort of why I'm putting these steps in place, these journeys in place. One of the problems that I have is it's building the business case. It's trying to show people what it takes to get this done. And what I am finding with AI, it's very much like, I don't know how many of you guys have done, I found that it's really easy to sell BI, but if your data is not, and AI is a similar type of thing, and if your data is not well defined and you don't have all of these structures and knowledge defined, you're probably going to produce rubbish. Okay, so and then you'll go out pretty quickly. So without the skills development and that business understanding of the value of this, I don't believe you can just jump there. I think it's too much of a jump for a lot of the business people to understand and for you to take it with them. I do believe you can go a little bit slower in terms of bringing this stuff out, and you can start to provide your data teams with the right tech tools and that, but you'll probably find that they're going to have to be doing some of it manually in the beginning. Okay, all right, so let's go. What I wanted to get to is an actual case study. This is a case study that I've done. I call it the cost of funding case study. It was done for econometricians. The problem that started was that they went out a request for data to what was referred to the reporting entities with no format definitions. So they just said to the people that needed to report the data, please provide us with all this information. There were no formats defined. Okay. And we then got a lot of the responses back. Unfortunately, we got multiple spreadsheets per each reporting entity. So that was another challenge in terms of where the data was, with all sorts of different connotations. And the big pain was that we had many workbooks and spreadsheets. So in total, we had 8 workbooks. We had 38 spreadsheets. That must have translated into the region of 45 data areas. We had 121 economic variables, and we had 20, at the end of it, when I was finished, we had something like 225,000 data points that had to be analyzed and assessed. The nice thing about it was that we were able to do a proof of value where we could remove all of the costly life cycle stages. Okay, so we could take the data life cycle. I'm sure you guys know it. We talk about plan, design, enable, create, obtain, use, enhance, and dispose. You remember that data life cycle, and we got rid of most of them except the use and enhance. Okay, and that's the next step that they have to go on to. And the process we applied was this process. We took them, first of all, we took the data sets, the Excel, all the different formats from messy to tidy. We then went from tidy to narrow, where we added the master data and the data quality. We're still having some interesting challenges there in terms of people getting the right periods. So there's some really nice discussions happening now, and people are starting to understand the value of master data. We then took it from a narrow to USS and from USS to wide. And the resultant payoff was that we had all of this in one wide data set. We could get it all into one wide data set. And that meant that every single series was comparable to another series, of course, if it used the same metric or the economic concept, for example, a yield across the different financial institutions. So we got conform data, and then we had the recognition of all the DQ challenges. So as I was building this, I was saying, here are all my problems. Can you see the different frequencies, the different volumes that were reported on by the different reporting entities? And so that was quite helpful. So this just gives you a simple example of some of the one data sets. I had to build a report of the data sets. And here are, as an example, the different observation types. So it's the repo rate, the call savings, yield, and this was all around risk, NCDs. So that these are all the different. Now this was for one data set, and notice all the different time frames. So you can see over here where we had aggregated data involved in it as well. Okay, so not just from 2006 to 2020. We also just had a snapshot in 2020. Okay, that was the one data set. Here is the summary of all of the work that we had to apply. And I just wanted to give you some examples of sort of what messy data sets look like. Okay, so you can see here, it looks very much like a pivot table. And we can now see that we have a reference rate, which is a length of funding. This was in the currency of ZAR. It had overnight. These were units, observation period units. Then we've got the observation type, which is spread and volume. And then we have the observation concept. And then these are all the values that we certainly can't share. So notice how when you get this Excel spreadsheet, there's a whole lot, and this is what we refer to as a messy data set, where we're not getting one column per variable. We're getting a whole lot of stuff that we need to fix. Okay, and then the same thing is expressed within the same spreadsheet. So here we've got data area 1, here we've got data area 2 in the same data set. One's expressed in ZAR and one's expressed in USD, but it's now related to the LIBOR index. Okay, so, and notice down the bottom here, there's almost a list of all the different financial institutions that we had to bring the data together for. Okay, so I'm just taking you through here, all the different challenges we had in terms of building up a context. In this case, these were actually economic variables, so they translated into an observation type. In this case, we had a whole lot of dates from 2001, and we had the observation types and then some other pricing units that were defined. Now, in this case, we almost had a balance sheet, right? So you can see here the balance sheet class, assets, liabilities, equities. We had the product segments, we had the different rate types. So now we had all these different complications that were coming in, and we were missing all sorts of different definitions in terms of product names for the balance sheet, different reference rates. So you can see, I hope this is just clear in terms of the challenges that these guys face to get the data together. So the proof of value was, could I, in one single run, get rid of all of or deal with all of these different life cycle stages? So what was the data architecture? We came up with a poly-based technology. What was the design? We built a conform data model. How did we obtain it? We got it from messy data sets. And we left it in a data lake, and we used data virtualization so that we could re-pull it at any point in time. How did we store it? We stored it in a conformed physical data model. And how did we enable it? We enabled it back to the econometricians in USS and WIDE. Okay. And this is what the conformed data model looked like. And there you can see the bridge table that I'm using. Notice how I'm getting having to get quite fancy here in terms of hierarchical structures to represent the balance sheet. And I was unable to do this without fighting with all the different interrelationships with the self-service analytics. Now, this was something that I was really chuffed about when I could produce a wide data set from the original USS table without doing any further transformation. So I could give the statisticians and the econometricians multiple data formats that they could work with, and they didn't have to stick to the UDM or the Unified Dimensional Models structure. So within a simple view, I could create the view, and this is what it almost looked like in Excel, where I had a whole lot of slices on top of the data sets, and you can see all the financial institutions, all the different curves across all the different periods, and I was able to present it, and they could say, okay, give me this period, which institution, what was the observation type, the units, the rates, and then the context. So was it a balance sheet, a BA 900, whatever it was, and I was able to produce the data set for them, and they could play around with this thing in Excel. So that was pretty amazing. All right, so just to do a quick roundup, and we can get to some of the questions. Okay, so if we go to the roundup, this section over here was what are the main ideas? That there is this transformation journey, right? There is an approach that you must go through, and be careful of jumping over, because then you lose the stuff that you developed on the journey. You don't build a team of people that have that understanding and skills. They don't start to see the standardized data format, and then they can't see sometimes how this automation and sophistication can be applied. All right, so the crossroad is the following, and this is almost where we left in terms of my proof of value or my business case to the businesses, to say we can continue beating this data, right? We can continue beating it and each time our data scientists and statisticians have to do that because we're too busy to build something. And the cost of this inaction is, well, you're going to be wasting these guys' time. 80% of the time is on this data wrangling. Now, these guys are, I mean, it's almost, I'm sure anybody who's worked in the insurance agency, insurance business, or within banking, where you get actuarial scientists doing this, and whenever I see them spending 80% of the time wrangling, I battle with it. You're not going to deal with these pains and the challenge that you've done a calculation that hasn't worked, and you've got data quality issues because they don't have time to analyze it. And at some stage, we are going to find the Guillermos and that are actually able to do this, right? They can take that data from the beginning, from messy, into a machine and start showing insights that your business have never seen before, and it's taking you 2 weeks, 3 weeks to get there, if you're lucky. So that's the challenge. These guys are getting it done. I think Guillermo actually showed us the demo that within 15 minutes he had the data to insights. Okay, so what is our offer? Our offer is contact us, and we'll show you. We'll share the journey with you. That's at dama.org.za. Why don't you just add there in the subject to stop the data wrangling, And then if you can give us just your current state of where you're at, so we have an understanding of how we can help you and what we need to do and the type of person. And that brings to the end of my discussion. So are there any questions? Any comments, questions? Sorry, I went through pretty quickly.
Right, so but it looked like you covered a hell of a lot there, Howard. Look forward to understanding it quietly in the background, and then I'll ask some questions when I got it.
Okay, sure.
Hi, Drew. Didn't know you.
Hello, Paul.
Howard, so in this approach, I mean, it's a nice recipe, right? So if your task was to be quite simple, so maybe not within the context of the data science team, right? Maybe you just need to, you still have your messy data to start off with, and you need to go through it and get, maybe just get an idea of what the data quality issues are,
right,
before you take it through the process. Using this recipe, would that also be a useful way to kind of systematically take a bunch of data sets through?
Certainly. So I was mentioning JG, and so if I just, JG was happy for me to share it. I don't know if he's on.
Okay, so no, it's because he always hides in the corner, and you kind of
he keeps quiet. So this was something that JG came to me, right? He came to me and he said, Howard, I've got a whole lot of data. I've got some really interesting observations that I think will work, but I'm battling to pull all this data together. So this was a case study done with Sanctuary Analytics, and these are local authorities that provide social education or special education needs. And they decision makers that need to make a decision of, can we send the kid to a local school, or do we need to send the kid to what they refer to as an out-of-borough school? And these are the decisions. Now, the cost is really expensive, and they're getting caught by not having enough money. So the problem was that they had no link between the special education needs, statistics, and the costs. So they couldn't work out what they were spending. They just knew they were overspending, and they were getting into trouble. They were overspending on their budgets. So JG has found a way of linking the two together, which was fantastic. But he really battled to put the data together. All right. So his pain was multiple workbooks, and I think I showed you that. These were the workbooks. Okay. So these were the workbooks that he was given to play with. And he was happy for me to, so each Excel has got a different workbook. Can you see here, SEN 2018, and so that's what he was fighting with. I'm just trying to get and then he had other problems where his grain was disconnected, so his financial was not at the level of special needs. Okay, so he got a budget figure for this area over here for the school, but it couldn't be allocated to the primary needs. Okay, and you can see JG's first attempt was basically every single data set, every single spreadsheet came into a table. Now, what happened there was that some of the geographies changed in the different periods from 2015 to 2016 to 2017. So they were allocated different numbers. And so you jumped around all over the place, but he wasn't able to tie it together at that point in time. So those data at different grains, the statistics were at the SEN level, so that was the number of counts, but the financials were at the school level. And so I took him through the exact same process. We went from messy to tidy, tidy to narrow, and narrow to USS. He hasn't needed the wide, so basically I stopped there. And once again, we've got a combined data set. So now the Power BI looks like this. So you can see the multiple fact tables. We've got the school financials and SEN, and we've got all the common dimensions on top. and each time he introduces a new fact table to bring some correlation, I don't need to link the fact table to all these different conform dimensions.
Mm. Okay. Just a couple of questions that I think would be valuable for others as well. So I think the previous presentations on things like taking it to the USS and the Pupini Bridge, maybe just we need to post those links as part of this one as well, so people can come back to it. I certainly would.
Right.
And then I'm wondering, like in this process, when would it not make sense to go with a bridge table? Would it ever not make sense to go there?
Yeah, it is interesting, and I found that it's somewhat dependent on your data team skills. Some of the BI guys just don't feel comfortable with that bridge table, and they are comfortable with the Kimball model. They've got all their tools sitting there, and so all of their stuff's over there, and they're not comfortable on going to that USS bridge table. So I found that almost that negative reaction to say that's not a proper star schema design.
Mm.
So
okay, so it's more a question of sort of background and philosophy of where you come from, as opposed to just sort of looking at it objectively and making a call whether it's useful or not.
Yeah, look, the bridge table, if you notice what the bridge table does, is that the bridge table has basically a row for every fact table row. Okay, so you're doubling up on that scenario.
Yeah,
you're doubling up on that scenario. But so what it is if you look at the bridge table, if I just show you that, if I magnify the bridge table, and I know Johan and them had all sorts of questions on this when Francesco did it. If I look at that bridge table, there's nothing but surrogate keys.
Yes.
So the compression is very good with that. And it was interestingly enough when I found, and then what I did as well, if you look at the fact tables, I've taken all the keys out of the fact tables. So the surrogate keys have been removed from the fact tables. All right. And
okay,
the reason I remove those surrogate keys from the fact tables is when I drop the fact table into the self-service analytics, it tries to join them up to existing tables.
Oh.
So so this is always what I like with a USS design is, can I basically point the self-service analytical tool at the database design, and it builds the process and doesn't get confused with joins going between the different tables.
Okay, sorry, Angus. Actually, I missed a bit of this because I had just something to sort out. But this whole thing, getting to these where you don't want to do these joins, because Angus, look, essentially, aren't we trying to really, because is that not what the data scientists really want? They really want denormalized tables.
Not necessarily.
Not necessarily. Okay, because I guess all wouldn't help. Okay?
So you are right. In some cases, they go for the wide data set, and that's the simple analogy is that of goal seeking within Excel. So all of the numbers are replaced by values. So you've got South Africa or you've got Buckinghamshire, whatever it is. But there are cases where certain algorithms almost want the tidy layout and not the wide layout. So they want it separated. So it's what I have found is that it's almost by implementation of statistical algorithm, the format that is asked for.
Can I just make this is just a comment, and this has got nothing, but this has got to make a lot to do with this whole design with denormalized tables and your normal data, actually data mart, okay, which because I found something like a columnar database like Redshift, okay, that is actually, you can design your tables denormalized because it's very efficient, very, very fast. You can do humongous data sets. But if you need that denormalized design, things like Power BI or Cognos or actually whatever of these front-end tools can very, very quickly take that denormalized table and actually push it into a normal or a data mart type of thing. Is that not really, because like if you do it that way, then you're always going to have these big wide denormalized tables which you can dump down onto a data lake and then let the data scientists start working off that. But if they need actually data mart, actually dimensional, your Power BIs and things like that would give that to you. Actually, sorry, that's a lot of things I'm been saying.
All right. So if I'm getting you correct, you're basically saying, why don't I just go to wide and then allow the self-service analytical tools to build the star schema, right?
True. Yes.
Okay. And yes, I can, because all the data is there. But what I have found is that it doesn't cost me anything to provide them with both.
Sorry, I'm missing you there. Like in what way doesn't it cost you to give them both?
Okay, so what I have done in a few of the situations is I produce Power BI data sets that have both formats, one being a proper star schema or a USS design, where everything's nicely partitioned and packed away in its dimensions and things like that. And I've given another, so almost what we're doing is we're giving Power BI templates, and this one was Alteryx does a great job on that, where you get all the joins right and the relationships right, and then they start with that and then they build their visualizations on that.
Okay, no, that's fine. I'm just thinking the whole pipeline. Then you start getting into things like actually maybe a data vault design, and then moving it up to the two-dimensional databases.
But I suppose what I'm trying to say is, in the pipeline, I'm having to get to the narrow and the USS. So it takes me very little as a data team to provide the statisticians both a USS format, a narrow format, and or a wide format. And the wide format is just a view, and they can really point R and put a data frame to it, and they've got the wide data set without anything. If they're not comfortable with that, they can go to the USS bridge table and they just say, load this with all its related tables, and they've got everything. So it's just, we really trying to get to a point where they are not having to wrangle the data in any shape or format to get this to start working.
Okay, cool, thanks.
Yeah. So technically you can you can go from the wide data set back to that, but I just find that I've done the hard yards. Just create a relational template for that data model, a Power BI template for that data model, and they can choose and they copy that thing and they create their own and off they go. So what we like to do is to say these are our curated data sets. Don't fiddle with them. Don't go and start playing with the joins on that thing.
Sorry, I must apologize because you were, I missed it somewhere along. You're talking about the USS, and that's a unified star schema. Okay, now, excuse me, it's a Monday afternoon.
Okay, you owe me a
now I know we're on the right page with where we're going. Sorry about that. I had a brain dump.
Brain freeze.
Or a brain freeze, yes, that's right. Cool, okay.
Paul, have I answered your question? I'm not sure if I got to.
Yes. I think there's more to be sort of unpacked, especially on if we get to a point where we understand what the data quality problems are. At that point in time, or actually to get there,
Yeah.
And maybe that can even be your next presentation now. It is actually okay.
Yeah, so I like what you're doing there is basically asking, where is the data quality side to this? And what I have done in quite a few of them is I like to build almost a quality dashboard where you start saying, I've got so many of these, so many of those, this is what it's made up of. So that goes with, when you publish these Power BI templates, you want the raw relationships and this data model, not the raw one, the messy one, but you want the data model with a data quality dashboard that keeps, when was it last refreshed? What was this? Where are the challenges? What areas do we have? How many schools? How many of this? How many of that? And so they have those elements all available to them, and you can test it at that stage.
Yeah, and there's going to be a period where the format of the data that you have is going to be most appropriate for the data quality tool to just read it and give you an analysis on it.
100%.
And that would be interesting as well. So I would like to see a presentation on that. A future presentation would be great.
Okay. Yeah, what I have done in the one area was almost in my bridge table, I marked the elements that were dirty in the bridge table. So I just had counters, right? So you use the different data quality dimensions, and you say you have an accuracy issue on this row, and then there was a whole lot of counting that happened. How many errors have I got on schools? How many errors have I got on academic periods? And stuff like that. And then you can almost just filter out those errors, and then you wouldn't get those rows in your calculation.
Mm. Yeah, that's cool. Howard, I think unless there's other questions, I was just the offer that you have there at the end of your presentation, maybe just for clarity, that is an offer coming from you from a demo context, right?
Yes, good.
What could people expect from an engagement or commercial expectations or anything like that?
So what I'm happy to do there is, as demos, just almost show them that there is a way, there is a recipe. They can choose to apply it themselves, or they can choose, for example, to talk to someone that can do it, and stuff like that.
Great. That was really interesting. I see most people have dropped off.
Yeah.
Is there any more questions that we can take before we end this meeting? Anybody? Show of hands or just start speaking? Doesn't look like it. So yeah, just to round off the recording as well, Howard, thanks a lot. It's really interesting. And each time you speak of this, I understand a little bit more of the of the pie. So and I think it's really useful. So just thanks for that. And then the next thing would be in a month's time. This is happening every first Monday of the month.
Yes.
And then our next demo meetup will be when?
It's on the 3rd week of this month. So that's where Happy's talking. It's on the 17th of March. So it's 17th of March. Yeah.
Yes. That's the chapter meeting, right? And there's special interest meetups happening as well.
Yes. So there are quite a few going on. There's data privacy happening in the 2nd week. The Wednesday, the 2nd week, that's on the 10th. We've then got big data happening in the 3rd week. That's on the Monday. That's the 15th. We've got the DAMA user group on the 17th. And then Modelware's also got there's a chat every Thursday to talk about different aspects of data management. Yeah.
Cool. And they can watch LinkedIn profiles. You guys are good to always make people aware. So if you're not following Howard, then please do so, and you'll get all that information as well on LinkedIn. So excellent. I think with that it's a wrap. So just again, thanks Howard, really appreciate it, and I think we can stop the recording.
Thank you.